Galaxies. These colossal structures are the building blocks of the universe. From the majestic spirals of the Milky Way to the giant elliptical galaxies and bizarre irregular ones, galaxies come in all shapes and sizes. But how do they form? How do they evolve over billions of years to become the cosmic masterpieces we see today? Welcome to Großdenken, everyone. In this video, we'll explore the incredible story of galaxy formation and evolution. From the tiny ripples in the early universe to massive galactic mergers, we'll uncover the science behind how galaxies are born, how they grow, and how they transform over time. Please support this channel by subscribing. That would mean a great help. Now let's dive into the cosmos and unravel the mysteries of galaxies. Our story begins nearly 13.8 billion years ago, with the Big Bang. In the first moments after the Big Bang, the universe was a hot, dense soup of particles. As the universe expanded and cooled, matter began to clump together under the influence of gravity. But these clumps didn't form randomly. Tiny quantum fluctuations in the early universe, minute differences in density, became the seeds for galaxies. We can still see evidence of these fluctuations today in the cosmic microwave background radiation, a faint glow left over from the Big Bang. What's fascinating is that these clumps of matter weren't just made of ordinary matter like atoms. About 85% of the universe's matter is dark matter, an invisible substance that doesn't emit or absorb light, but exerts a gravitational pull. Dark matter played a crucial role in galaxy formation, acting as a cosmic scaffolding for the first galaxies to form. Roughly 200 million years after the Big Bang, the first galaxies began to take shape. These early galaxies formed when gas, mainly hydrogen and helium, fell into dark matter halos. As the gas collapsed under gravity, it became dense enough to ignite nuclear fusion, giving birth to the first stars. These galaxies were much smaller and less organized than the majestic spirals we see today. They were chaotic and full of young, massive stars that burned brightly but lived short, violent lives, often ending in supernova explosions. These early galaxies were also responsible for one of the most significant transformations in the universe's history: reionization. The intense radiation from the first stars and galaxies reionized the hydrogen gas in the universe, making it transparent and allowing light to travel freely, shaping the universe as we see it today. Once the first galaxies formed, they didn't stay small forever. Galaxies grow and evolve through two main processes: gas accretion and mergers. Gas accretion. Galaxies pull in surrounding gas from the cosmic web, a vast network of filaments made of gas and dark matter. This gas fuels star formation, allowing galaxies to grow over time. Mergers. Galaxies often collide and merge with one another. When two galaxies merge, their stars are flung into new orbits, creating larger, more massive galaxies. These mergers can trigger bursts of star formation and dramatically alter a galaxy's shape. For example, spiral galaxies can transform into large elliptical galaxies after a major merger. You know, our own galaxy, the Milky Way, has actually experienced quite a few mergers throughout its history. And, well, it's set to collide with the Andromeda Galaxy in about 4.5 billion years. When this happens, the two galaxies will combine to form a massive elliptical galaxy. Not all galaxies look the same. Astronomers classify galaxies into three main types based on their shape. Spiral galaxies like the Milky Way have a flat, rotating disk with spiral arms. They're rich in gas and dust, which makes them excellent sites for star formation. Elliptical galaxies, on the other hand, are more rounded and lack the structure of spirals. They contain older stars and very little gas, so they no longer form new stars. Irregular galaxies are, well, chaotic and don't really fit into the spiral or elliptical categories. Many irregular galaxies are actually the result of galaxy interactions or mergers. It's interesting to note that galaxies can evolve from one type to another. For example, a spiral galaxy can become an elliptical galaxy after a major merger. Meanwhile, interactions with nearby galaxies can distort their shapes, creating irregular galaxies. At the heart of nearly every large galaxy lies a supermassive black hole, millions or even billions of times the mass of our Sun. These black holes play a crucial role in galaxy evolution. When gas falls into a supermassive black hole, it heats up and emits enormous amounts of energy, often in the form of powerful jets. This is known as an active galactic nucleus, or quasar. The energy released by these black holes can regulate star formation in galaxies. If too much gas is heated or expelled, it can prevent new stars from forming, effectively shaping the future of the galaxy. So, while supermassive black holes are incredibly destructive, they also help control the growth and evolution of galaxies on cosmic scales. What does the future hold for galaxies? As the universe continues to expand, galaxies are moving farther apart due to dark energy, which is the mysterious force driving the acceleration of cosmic expansion. Eventually, galaxies outside our local group will become so distant that their light will no longer be visible. Over billions of years, star formation will slow down as galaxies run out of gas. The universe will become darker and colder, with galaxies evolving into quiet, dead systems filled with old stars and remnants of their once vibrant past. Galaxies are more than just collections of stars. They're the story of the universe itself. From their birth in dense clumps of gas and dark matter, to their growth through mergers and their transformation over billions of years, galaxies are constantly evolving. Every star we see, every planet we explore, and even our own existence is tied to the life cycle of galaxies. By understanding galaxies, we uncover the history of the cosmos and our place within it. Thank you for watching. If you enjoyed this video, don't forget to like, subscribe, and share your thoughts in the comments below. What's your favorite galaxy and why? Let me know.